Hi, welcome to my video on solving related rate word problems number 3. Again, more examples how related rates are working. Number 1, a parallelogram has its area changing 33 square inches per minute. The base is changing at 2 inches per minute. The base has a base of 9 inches. Find the rate of change in its height when the height is 5 inches. So it says, let's see what we're given. Look, write down what we're given. We're given a parallelogram. That's my abbreviation for parallelogram. Area is changing, so that's d, dA, dt. So the area is changing at 33 square inches a minute. And the base is changing. So the base is changing. So that's d, b, dt. The base is changing at 2 inches per minute. And it says the base is 9, so the base is 9 inches. And this is, we want to find the rate of change when the height is 5 inches. So let's say, right now the height is 5 inches. So we're trying to find the rate of change in the height. So that's d, h, dt is what we're trying to find. So we have a parallelogram, and a parallelogram is just a rectangle pushed at a shape. So a parallelogram has a height between these two lines are parallel to each other, and this is the base. So the area of a parallelogram is base times height. So we're given dA dt, so we have to look at the area. So let's do d dt on each side, so that's dA dt, and we're doing d dt, and this is f and g, so the derivative of b is 1, so that's b dt, dB dt times h plus the b. Remember now this is the f and that's the g, so the derivative of f times g, and then it's the derivative f, which is the b, times the derivative of h, and the derivative of h is 1, so it's dh dt, because there's a product. So now let's see if we can fill in the unknowns here. So the area is changing at 33 square inches a minute. dB dt is 2. The height is 5. B is 9. And we have to find dH dt. So that's 33. 2 times 5 is 10. 9 dH dt. So notice this is, this is square inches divided by time. And so this is 2. That's 2 inches per minute. And this is 5 inches. So 2 inches per minute divided by times inches is the area in terms of times. So now we can, this is an area in terms of time. This is an area in terms of time, because now the two of them are rates. So now we can go 33 minus 10 equals 9 dH dt. So that's 23 equals 9 dH dt. And we divide both sides by 9, so dH dt is equal to 23 over 9. So that means that dH dt is 23 over 9 minutes in inches, so it's inches per minute. Again, this time we have the unknown is on the right side, so we have to solve it. All the previous ones, all the unknown was right here on the left side, but I decided to do a couple of problems finding the unknown on the right side. Now we have another one to do. The volume of a sphere increases at a rate of 72 pi cubic meters a second. Find how fast this surface area is changing when the diameter is 12 meters. And everything is okay. I got meters here and I got meters. So let's see what we have. Let's again write down what we're given. We're given a sphere, and the sphere is just a, if I can spell it, PH. Okay, sphere. And the volume is changing, increasing. So that's dV dt is 72 pi cubic meters a second. And we're trying to find how fast the surface area when the diameter, so we're given the diameter, D, I'll use D for diameter, is 12 meters. And we have to, what's the unknown? So we're trying to find how fast the surface area. So that's dSA over dt, how fast the surface area is changing. So let's see, we have dV dt and we have a surface area. So a sphere, we said a sphere is a ball, but let's see, now I'll draw this on the back to indicate that's the back side that you can't see. And there's the center of the sphere or ball, and that radius is 6. Oh, I said 6. The diameter is 12. I'm kind of ahead of myself now. We said that we need the radius. So if the diameter is 2r, that means that 2r equals 12. So r is equal to 6. So the radius is 6. I got ahead of myself then. I put the radius in without working it out. I was given the diameter. So now we have a volume of a sphere, and the volume of a sphere is 4 over 3 pi r cubed. And we have a surface area, and the surface area of a sphere, surface area, is 4 pi r squared. And actually a trick, or that I do, that learned, is that because we did calculus, if you do the derivative of this volume, you get the surface area. So the derivative here, the 3's cancel out, we get 4 pi r, but the 3 decreases by 1. So I learned it after I did the derivative of the volume as the surface area. Now, we have to go, and we have dV dt, so let's work out ddt on the volume. So it's dV dt, and this is 4 over 3 pi. So the derivative of r cubed is 3r squared dr dt. So that means dV dt is 4 pi r squared dr dt. The 3's cancel out, so we get v dt. Now, we know that dV dt is 72 pi 4, and r is 6, so we put 6 in here, make sure we fill in all the, and we got dr dt. So we got dv dt, we got r, the only unknown is dr dt, so we work this out, 72 pi. That's 36 times 4 is 144 pi dr dt. And so we divide 72 pi by 144 pi equals dr dt. And the pi's cancel, and that's 1, 2. So that's 1/2 dr dt. And dr dt is the radius in terms of time, so it's meters per second. So it's meters per second. Now, so we have to work out what the surface area is. So we have to do dSA dt on this side. So d dt on both sides is dSA dt. And this is a constant of 4 pi. So the derivative of pi squared is, derivative of r squared is 2r. And it's dr dt. So we're trying to find what the surface area is in terms of time to rate. So this becomes 8 pi r dr dt. And so we had 8 pi, and the radius, we know the radius worked out to be 6, and dr dt worked out to be 1/2. So we work that out. 1/2 of 6 is 3. 3/8 is 24 pi. And again, it's the surface area over time. So it's meters, so it's meters squared over time in seconds. So again, another one more, a little bit different. Again, in this equation, I solved it for the unknown that's on the right side, knowing the known is on the left and the r is known. And then we had to substitute into the surface area. So we did the volume and we did the surface area. We had to do the volume first, derivative, and then take that unknown that we found, sub into the surface area. Again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.